So in this video we are going to discuss 6th chapter integration, reduction formula we are discussing. So first reduction formula is find the reduction formula for integral sine power nx dx for an integer n is greater than or equal to 2 and hence deduce that integral sine power 4x dx. First, taking that to find the reduction formula, in is equal to integral sine x power n or sine power nx dx. So, which can be written as in is equal to integral. So, this is sine x power n minus 1 into sine x power n minus 1 into sine x dx writing. So here, let u is equal to taking as a sine x power n minus 1 and v is equal to, taking sine x. We know that, so the uv formula for integral uv dx is equal to u into, so integral v dx and minus integral of u dash into, so integral v dx of dx here, of dx. So now just substituting the u and v in this formula, in is equal to, so here u is sin x power n minus 1 into v is integral sin x dx and minus integral of, so derivative of sin x power n minus 1, derivative of sin x power n minus 1 and integral v is integral sin x dx and of dx here, So now we know that integral sin x, integral sin x dx is equal to minus cos x and also, so derivative of x power n is equal to n into x power n minus 1, this is n into x power n minus 1. So now in is equal to, here sin x power n minus 1 is writing as it is and integral sin x is writing as minus cos x and minus integral, so sin x power n minus 1 derivative is like x power n, so n is here n minus 1, into sin x power n minus 1, that is sin x power n minus 1, so into derivative of again sin x, into integral sin x is minus cos x, so minus cos x of dx, this is minus cos x of dx. So now which is equal to in is equal to, so here minus, so sin x power n minus 1 into cos x and here, so integral sin x is minus cos x, this minus into minus is plus and n minus 1 is constant with respect to x, n minus 1 into integral, so this is sin x power, so n minus 1, that is n minus 2, so into sin x derivative is here, we have cos x, derivative of sin x is cos x into cos x dx here, of dx, so into cos x of dx. So now which is equal to in is equal to, so minus sin x power n minus 1 into cos x and plus n minus 1, so into integral, so here sin x power n minus 2, so into sin cos x into cos x is here, we have cos square x of dx here. See, we have the identity here, so sin square theta plus cos square theta is equal to 1. So from this we can write cos square theta is equal to 1 minus sin square theta. So that's why here this cos square x is also replaced by 1 minus sine square x. Now further it can be written as in is equal to minus sin x power n minus 1 into cos x and plus n minus 1 into integral. So this is sin x power n minus 2 into, so this cos square x is writing as in, so using this identity in terms of x writing as 1 minus sin square x dx. So now further in is equal to here minus sin x power n minus 1 minus sin x power n minus 1 into cos x and plus here n minus 1 plus n minus 1 into integral. So these two are multiplying with sin x power n minus 2. So now we get integral of sin x power n minus 2. So into 1, that is sin x power n minus 1, n minus 2 and minus. So this is sin x power n minus 2 into sin square x of dx. Now further we here, so now in is equal to, further which is in is equal to, so in is equal to here minus sin x power n minus 1 into cos x. So this is minus sin x power n minus 1 into cos x and plus n minus 1. So plus n minus 1. So into, so integral of sin x power n minus 2. So integral of sin x power n minus 2. And here if you add the powers here, bases are equal. So that's why we get minus. So this is sin x power n minus 2 and plus 2. So of dx here. So here plus 2 minus 2 gets cancelled. So we have here in is equal to minus sin x power n minus 1 into cos x and plus n minus 1. So into here. So integral if you give for both the functions, then it becomes integral sin x power n minus 2 dx and minus integral. So this is sin x dx, minus integral sin x dx. And further here, which can be written as now in is equal to, so minus sin x power n minus 1 into cos x plus n minus 1 into here. So integral sin x power n minus 2 dx we can write in minus 2 and here minus. So integral sin x power n dx which can be written as in. So now which is equal to minus sin x power n minus 1 into cos x and plus if you multiply these two with n minus 1, then we get n minus 1 into in minus 2 and again plus into minus is minus. So n minus 1 into in. So now already the left hand side we have in and bring that minus n minus 1 into in to the left side, it becomes plus n minus 1 into in. So which is equal to minus sin x power n minus 1 so into cos x and plus n minus 1 into in minus 2. So now here taking in common, so then we get 1 plus n minus 1, so which is equal to minus, so sin x power n minus 1 into cos x and plus here n minus 1 into in minus 2. So now here plus 1 minus 1 gets cancelled. So now in into n is equal to minus sin x power n minus 1 into cos x and plus n minus 1 into in minus 2. So then if you send this n to the right side, it becomes, it can be written as 1 by minus 1 by n into sin x power n minus 1 into cos x and plus n minus 1 by n into in minus 2. So this is the reduction formula for the integral sin power nx dx. But we have to find, hence from deduce that integral sin power 4x dx. Now I4 is equal, that means put n is equal to 4 in the same formula. I4 is equal to integral sin power 4x dx which is equal to, so minus 1 by 4 into sin x power, so 4 minus 1 into cos x, and plus this is 4 minus 1 by 4 into I 4 minus 2. So then we get here I 4 is equal to minus 1 by 4 into, so this is sin x power 4 minus 1 sin cube x into cos x, and plus this is 3 by 4 into I2 here. So now further again, which is equal to minus 1 by 4 into sin cube x, so into cos x, again plus 3 by 4 into, so I2 also again now take n is equal to 2, substitute in the same formula, minus 1 by 2 into, so sin x power 2 minus 1 into cos x, plus 2 minus 1 by 2 into I2 minus 2 we get. So now which is equal to minus 1 by 4 into sin cube x into cos x, and plus here, so 3 by 4 into minus 1 by 2, that is multiplying with plus 3 by 4, minus 3 by 8 into sin x into cos x, and 3 by 4 into 1 by 2 here, so that is plus 3 by 8 into, so this is I0, now which is equal to minus 1 by 4 into sin cube x into cos x, and minus 3 by 8 into sin x into cos x, and plus 3 by 8 into, so integral I0 means again you have to substitute here, so n is 0, then we get here sin x whole to the power of, so 0 into dx. So now I4 is equal to, so minus 1 by 4 into sin cube x into cos x, minus 3 by 8 into, so this is sin x into cos x, and plus 3 by 8 into integral, anything power 1 is, anything power 0 is 1 dx. Finally we get I4 is equal to integral sin power 4x dx is equal to minus 1 by 4 into, so this is sin cube x into cos x, minus 3 by 8 into sin x into cos x, plus we know that integral 1 dx is x, so that's why this is 3 by 8 into x plus c. So like this we can find I4 is equal to, so integral sin power 4x dx is equal to minus 1 by 4 into sin cube x into cos x, minus 3 by 8 into sin x into cos x, plus 3 by 8 into x plus c. Like this we can prove.